Let me see if I see. Okay, so as you said, so this is a joint work of the four of us. Cécile, with whom I work now since 4 years on the 4 years, I think, maybe more.
5 years, I think.
5 years on the flip class. Roland, also we started working on that even 1 year before probably, and then Himanshu, we joined the club 2 years ago, and then he worked a lot on the data. So I will present, but we are, Himanshu is not here, but Cécile and Roland are also here.
Himanshu is here.
I'm here.
Where are you? Ah, okay. Hi, Himanshu.
Hello.
So, but the subject of today's presentation is not specifically the flip linear algebra, but it's a little bit more on really inclusive teaching. And one element is flipped in the class, but this is really the second one. So when I will present make sure that you understand that the first half, which is a very short presentation, but the first half is not about flipping the linear algebra. It's really about some other results that we found thanks to the flipping experiment, but it is not conducted on the students who's actually doing the flipping class. So the results is of students who went to a regular class. So I will first describe quickly the data so that you understand what we are talking about. Then seeing one possibility of trying to help the students, which is reducing the stress at the exam. So as I said, non-flip. Then in the second part, it will be about flipping a class. So what are the results on inclusion when talking about when doing a flipped class, and then we will have plenty of time for discussing, because I have something like 20 slides, but really it will be quick, so we will have time. And the sponsors of it are SMA, CAPE, and LEARN. So first, last year, Roland asked the student to do a literary review about the impact of time pressure on mathematical performance, and then Andreas Lefebvre he gave us a nice report. And well, among the things that he reported to us, so there are these 3 papers. So one well, they show that compared to individual students with low anxiety in doing math, so those with high anxiety exhibit performance deficit when they do arithmetic tasks. So this is probably it's obvious to most of us, but this is really shows that this is one problem. Then again about fast deadlines conditions, so it's a little different, but then the third one will combine to fast deadline conditions. So they prevent the students to use procedural strategies. So students tend to recover from their memory instead of putting in place a procedure, so like a methodology. So, and these for when you have hard problems as you have in this EPFL, I mean, you cannot just recover it from your memory. You need time, and the short deadline may be a problem. And indeed, Hunt and Chandu, they say that they found that arithmetic performance among this math anxious individual is worse when a time limit is given. So this is what exists, or part of what exists. Now we have some evidence that this is also happening in our in our school, in linear algebra at least. So first remember what is the linear algebra course. This is the first year bachelor course. We have six weights, which are roughly 6 credits for 1,700 to 2,000 students. And it's in the first semester, and it counts a lot towards the success of the first semester. And what is nice when doing this study is that we have 7 different teachers, and they all agree to do 80% of the exam together. So we can do some comparisons. And the study that we did was during 3-4 years, say. So year 0 was before we started, and year 1 we have 519 volunteers, year 2 373, and then 534. And the first part of the talk will be about the results between the comparisons of the results between year 2 and year 3 for the volunteers that are here, minus those that actually came to my flipped class. So these are we will study students that didn't do the course with me. Okay, so this is really about students that went with other teachers. And in the second part, instead, we will compare the population for the year 1 and 2, those that came to me and those that didn't come to me but still were volunteers. So there were, in the year 1, there were 519 volunteers, 410 were in a regular class, and 109 were with me. I flipped the class for 5 weeks, and then the second year, 273 against 373 volunteers, among which 202 came with me. And then this part we don't show comparison in year 3 for the second part. So first part, year 2 versus year 3, but also without, and here, Himanshu, and thanks for that you are here. If I say something bad, then you say, no problem. So Himanshu did the analysis of this data. And so for year 1, we see there are at least 4 macro populations. One is those that come from CMS, others that comes from MAN, and others are repetitors. But we focus on new ones, because for all these students, there are some, there are students who already faced EPFL and may also have some previous knowledge that is much different from the new. But in the end, we see from the numbers here, 124 and 253 women and men students, and the other numbers are smaller. So this is actually the big population that we study in the first year, and in the second year is the same. So we take the new students, and then in these new students there are another 4 groups, and this is about the background, and we will study in particular the influence of the background on the results. So when we talk inclusiveness in this talk, it's more about so we know that the French people and the French students and the Swiss with math physics, they are strong in mathematics and physics. So they have really a strong background, and this is accounts for 2/3 of the population of the first year. And then we have students with a Swiss high school, but they didn't do math and physics option. So these have a weaker background in math, and then we have other students. So we focus on these 3. So we will either study the 3 together, or we split the 3. And then what happens if we reduce the stress at the exam? This was not a foreseen experiment. What I show is a retrospective study. What we did was, because we thought it was better like that, we changed from year 2 to year 3 the number of questions in the exam. So this first line is the common part of the exam, and we had 16 plus 8 multiple choice questions in year 2, and then in so-called open part, so a question where the students have actually to develop their answer, and then for a total of 20% of the exam for 90 points. And then the year 3, we reduced by one, not many, one computational question and one theoretical question in the multiple choice. And then consequently, we reduced a little bit also the part, the specific part of the teacher. So again, this is the common part, and this is the common part. So we will analyze the results in this common part. But the results from these little changes is that year 3 exam is shorter. Actually, there is one less subject in the common syllabus. Well, many teachers did it take anyway, but formally there were one single subject less in year 3. So now we can see the results of the exams. And well, here is the students coming from France. Sorry. Students with a math and physics background, and these are the weaker ones. And this is year 1, year 2, year 2, year 3, year 2, year 3, year 2, year 3. I mean, the students with a strong math background, they perform the same. So there is no significant difference, statistically significant difference between the 2 years here, neither here. Okay, it seems a little bit worse, but in the end, it's not statistically, it's not significant even. So you see with the standard deviations, we are really within the same ranges. While for weaker students, the difference is significant. It's really, it's really a big difference. And if we split from men and women, we see that actually the students who are getting the most out of the change are the men. So the women are also doing a little bit better, but if we just look at them, we don't see it statistically significant. For the men, it is, and together still, the two populations together is statistically significant. Now, if we could look at the grade, so before I was looking just at the points, and actually not the points, but the normalized scores about the point. So what does it mean? Is it this a 1% difference? Is a 50% difference? Now, if you look at the grades, so this we are more used to, so between 0 and 6, the grades, we see that actually for the grade 1, so the common, students, women and men, the difference in grade goes from 225 to 325. So it's actually one full point of grade. So one point in the grade of difference by just these two questions removed from the exam. So here you see the p-value of the gray curve. Sorry, it genders together. It's really the p-value is really low. So it's statistically significant. So this is it for. We don't have other results on this, but we think that it is important that we understand that the pressure, the time constraint during the exam actually has a significant impact in the results of the exam for students with a weaker background. And here we may say, well, but in the end, in year 3, they do the results is the same. So it's not because of their background that they could not succeed in year 2, it's because of the time pressure. Okay, so to me, this is very important to understand. Okay, so this finishes the part of the exam, and now more on flipping my class. So maybe quickly about the course design. We will compare year 1 and year 2. And in the year 1, so we had 100 students.
Simone,
yep.
Do you want to take some questions maybe on the first part? I see some questions in the chat, sorry.
Yes, I didn't see the chat. Thank you very much. Yes, I want to see.
A question from Jessica asking what was the difference in terms of minutes between the exams in year 2 and year 3 in terms of time, actually?
Yeah, very good question. None. No difference. So 3 hours for year 2 and year 3 hours for year 3. Okay. Other questions? We can also discuss at the end, but if you have questions now, please do. Yes, we have time. Okay, so now flipping a class. So here, because well, also because I was not used to teach a flipped class and to prepare, etc. But at the same time, to actually see every year to have an increase in the part of the flipped class, to not put students into a difficult situation. Say that the finding where the flipped class is very bad for students, then okay, if you found out about it in the first year, then we can stop and say, okay, go back. We didn't cause too many problems, but in the end there was not big problems, so we went to a flipped class for 10 weeks out of 14, and then actually in year 3 we had the full semester which was flipped. So the design of the experiment was that they were all volunteers, and then 400 of them got something like a placebo, meaning that they went to a traditional class. In the second year, there was only 373 students. We wanted to double the number of students coming into my class. So there were 170 students which got placebo. And then these are the numbers that came to me. And then we will compare the students from we say it's a control group for those that are volunteers but not in my class, and then flipped for those that are volunteers in my class. Some numbers. So the number of points in year 1 that the mean was 40 for the control group and 38 for the second, and the p-value of the difference says that the difference is not significant. And in year 2, while the difference is even lower, we removed the questions with the discriminatory index lower than 0.33, meaning that those questions that I mean, usually you would like questions that are easy and those that are more difficult, and you expect that the good students answers correctly to the difficult ones, or most of them, and then almost everyone answers correctly to the easy ones. Well, there are questions where actually the worst students says the answers correctly, and the good ones no, and somehow we remove them from the statistics, because we think that this may be a sign that this question is not so well designed. Anyway, we decided to remove those. And then, so you see there are less questions. So the mean now is 31 and 31.7 for the control and pilot in the first year, and 33 and 32 almost for the second year. And again, the populations are not distinguishable. Again, we filter out new students and then the 3 subgroups. And then if we compare the students in the control group, so these are the students who went to a traditional class, and these are my students, there is no difference between the 2 populations. If you split the gender or not, I mean, the populations are the same. p-value is larger than 0.1. So no big influence of the flipped class on the students' results. On this part, B and C, meaning that we'll only look at those parts that were flipped. But then if we split again with respect to the background, we see that so in both years, the control group actually showed two different populations when looking at the people with a strong math background and a weaker one. While in the flipped class, well, there is no influence. I mean, there is no splitting of the population. Well, here maybe it's not so clear, but here you can see it clearly. Okay, so the with the flipped class, you end up with a population which is not distinguishable anymore. While in the control group with a traditional class, you actually keep the differences. So the conclusion for us, it is that, well, the flipped class, we don't know if it is better in general, but it is better in terms of inclusion. So it's more inclusive. Well, somehow we see the trend. The trend is not significant, but the fact that the populations are now mixed means that we are actually inclusive. Then what does Swisspan stand for? Sorry, I said it quickly at the beginning. It was the PAM says on Physique Application de Maths. So in Switzerland, we have a high school with options, and then the students can choose options among many different possibilities, and one of them is to actually do a more deep course in math and physics. And these students are usually, I mean, we see in the statistics that these students actually succeed better at EPFL. But yeah, for me, what is important to understand is are these the only students that can succeed at EPFL, or are there other students that can succeed at EPFL as good as them, although they didn't follow like the golden route? So and I mean, it's important that when the students are 18, that may change their mind. They may be interested in engineering at EPFL and say, okay, now I want to start. I think it's our mandate to make sure that these students got the education that they deserve, which is succeed at EPFL if they can learn what we teach, if they are good enough to understand what is needed to go in the second year. We should not just select them because they did something more mathematical and physics, more physics before coming to EPFL. And I think that this is what happens here.
There's another question, Simone, just before, maybe briefly, what differs in a flipped class compared to a traditional class? Yeah, you could illustrate.
Yeah, let me see if I have a small, yeah, here it is. So, okay, a regular class, usually you teach the material with them on the blackboard or on slides, whatever, but the basic material is taught in class. Then you have the exercises, and they can do some of them with the students, with the teaching assistants, and some of them at home. In what we did when designing the course with Cécile, was saying, okay, they will have to watch, I mean, take notes or learn a MOOC. So there was a MOOC by Donna Testerman on linear algebra that was tailored for our first year course. So they do videos, they do some quizzes, not too many. And after the video, during the video, they have to take notes. This is they do before class. Then during class, we do exercise essentially. And with clickers, now with the Zoom, you all know that we can also do polling. So with that, I make them vote, and then I can detect when there are problems. It also triggers questions of discussions, because when you actually do the exercise and you don't understand, then the students actually ask. And then I can explain deeper or less deeper, depending on their understanding. And after that, they have the regular exercise session. So this part are the usual hour that they have to contact with me, and then the exercises with the TAs. And then if they didn't finish the exercises, they can go back at home and finish the exercises. But typically, they have less exercises to do at home than usual, but they have much more to do in terms of learning. Does this answer? Cécile, you want to add something?
That was great. I hope it answered the question, if I understood well the question.
Difference in exercises. Actually, in the end, my philosophy is that if a course exists, then I take the traditional class with the exercise sheet, and I take the exercises that I do with them from the existing sheet. And so I cut the sheet in two. Half of it I keep it for me doing the flip part with them. And then the second part is for the regular exercise session. And if I could not do everything of this half, then I just put it on line 2 so that they know. Maybe another result, which is not yet significant in terms of p-value, so 0.6, but still almost significant, is that if we just look at the background in terms of reinforced mathematics, so there is not a difference between the option, but between just the level of math that the students do at the high school. So all the French and all PAM have a reinforced mathematics. So this is okay. And so we look just at those students, those who did the reinforced mathematics. So somehow we can compare the grades. So we split the groups between a low grade and high grade at high school in this strong math. And then we look how they did here. And of course, there is a big correlation between what they do at high school. If they were low, then they have a low grade. If they were good, then they have a high grade. Good. This is for the control group. But then in the flip, there is something weird going on, and we don't have an explanation also because the p-value is not low enough. But the women in the flip class, well, they were weak at the high school, but actually they were as good as the strong men and women when coming here at TPFL after following the flip class. It's not, this is, we don't have an explanation, but I think it's important that we say it. Okay, so to conclude, well, stress at the exam, we think that it has an influence on the results of the students, a significant influence. And our analysis shows that weaker backgrounds, those with a weaker background are those who are mostly influenced by the times constraint. So stress meaning stress and times constraint. I should have written. And then flipping a class, well, first there is a demand from the students. That was also a conclusion that we had in our study. But if we look at new students, flipping a class is more inclusive in terms of background and apparently also on gender. Okay, I think I finished. I don't know if Cécile, Himanshu, Roland want to add something. And of course, we are all here for questions.
Great presentation, Simone. Thanks.
Thank you.
Yes, I think we can open the floor to questions. First, maybe a round of applause for this presentation. And I already see that Ilya has a question. Go ahead, Ilya.
Thanks so much, Herman. Thank you, Simone. It was very interesting. I've just got one question. This is one set of results from 2 years. Will you be repeating the experiment to make sure that there isn't some artifact based on particular questions or the way they were posed or the particular group of students you had in those 2 years to make sure that these results are repetitive?
So there are two parts of the answer. First, statistically, so the number of students that we had, there were a lot. So I think that this is okay. What is true in your question is that what is the influence of the teacher? What is the influence of the other teachers? Okay, the other teachers are 6 or 7, so that should be okay to actually dilute the responsibility of the teachers on the other side. But on my side, there may be, I mean, there is also the fact that I was learning how to teach a flipped class. Yeah. We wanted to, we actually planned in September, last September, to have another teacher doing this experiment. But then because of COVID and the online class, this would not make any sense. And now it's almost impossible to do this again because many teachers actually adopted a flipped format last semester, and they will continue next semester even if it will be online. So we cannot anymore have such a nice splitting between the students, because what I didn't say is that in our experiment, all the other classes was traditional, and the students coming to me came from all of the sections. So they were volunteers from any engineering section. And now it would be weird, difficult also, well, both practically and ethically, to set it up again. Yeah, now next semester for analysis, I'm going to teach it for the first time flipped. Maybe I will be the only one, but I don't think it makes sense to do the experiment there, because again, it would be the same teacher, and you need somebody who steps up to teach a flipped class. It takes a lot to prepare and also, I mean, train himself.
Thanks so much. In your answer, you were actually focusing on the flipped classroom. I was fascinated by the fact that for a relatively small change in questions, in open questions in the exam, so it looks like a relatively small reduction in stress, there is a measurable change, particularly for the weaker students. That's the result that I find really incredible. And yeah. I'd like to know whether it's a repeatable result, whether there's any evidence that should be and could be introduced more widely. Yeah,
I agree. The big problem is that every time you change something in the exam, there are consequences for 2,000 students. And the only way to do a real experiment is to do it in the exam. So, I mean, this is, as I said at the beginning, this was a retrospective analysis. Doing a perspective analysis, I think, I don't know if I would agree to it. It's really different. Yeah, there are many questions that are difficult to answer. Another question is, well, this last semester we changed the exam again, but not for these reasons, but for trying to see if an old version of exams. So how did we change the exams during the years? So we took a very old exam, modified it, of course, but on the basis of the old exam, we prepared an exam which, well, a little bit more difficult than 10 years ago, but still. And the results in linear algebra were just excellent. I don't know if it is because of the COVID and the students worked more, but you see, you change a little bit and then you have changes in the results, and it is difficult then to say, okay, when were we right? Are we, what are we doing wrongly? I don't know. So difficult to do experiments on exams.
Yeah, I mean, there are so many factors that are beyond your control that deconvoluting the results is a challenge.
Yeah, yeah. By the way, because of the change between year 2 and year 3 in the exam, as I said here, we then were not able. I mean, we could not compare results from year 2, year 1, year 2, year 3 for the flipped class, because we changed so much that it's difficult to then compare the years. Yeah.
Thanks very much, Simone.
Thank you. Mark, you raised the hand. Would you like to ask?
Yeah, so thank you, Simone, and everyone for this wonderful presentation. I just would like to ask you if you have any feedback from students in the sense that they have reduced their pressure and anxiety. Because, I mean, I can see that the changes that you made in the exam might have reduced the workload. But I mean, the interpretation that you make is always in the sense of that these have consequences on the effects of students. You talk about, you know, pressure and anxiety, but we could also interpret it only in cognitive terms. I mean, in the sense that you made the exam easier by reducing the workload. So do you have any feedback from students that they actually decrease their anxiety and sense of pressure? Thanks.
Thank you. Yeah, very, very good question. The first, the reduction in terms of subject was really tiny. So out of, I don't know, this is like a reducing of 2-3%. I had to put it in the slides because this is actually what we did. But personally, I think that was really a tiny bit. And moreover, many of the teachers did it anyway. So we didn't announce the changes in the exam. So the number of questions and so on was not announced, which has two consequences. The first one is that they were not, well, they could not expect to be less anxious because they didn't know. And even during the exam, maybe they didn't figure out that there was less stress. So it's true that here we are not measuring the stress itself, but only the fact that the consequence was that they had more time in the end to come back and think a little bit more. Okay, so yeah, this I think is we should be careful on how we present it. We didn't reduce the stress because we didn't announce it, but we gave them more time to think during the exam.